Thank you very much, Ian. My first slide, I want to introduce the engagement of Atkins. We've actually been involved since 2005. We have had 450 people and engineers, actually at some stage up to 1,000 engineers involved in London 2012. This has been ranging from structures, bridges and highways, parkland public realm, utilities, enabling works, river edges engineers and wetland bridges. In terms of inspiring a nation, I also think that the UK has actually managed to inspire the world, and also in terms of engineering, because there was a competition for the first time at London 2012, which was who would be the preferred engineering design providers, and Atkins won that right. And this is the first time that an engineering company, as part of Olympic Games, have actually been a sponsor. So I think this is putting engineering more on the map on the global basis. Going back to the history of Olympic Games and London, actually the first time the Olympic Games was in London was in 1908, and the reason for that was because in Rome there was an eruption of a mountain, and therefore they couldn't actually have it happen, so it came to the UK. And so they built, so just to compare in terms of infrastructure what happened then to now, I put these images on. So this is actually White City, and that stadium was reused in 1948, just after the war, where the Olympic Games was also held in London. And in terms of the, back then there was 4,000 contestants and 59 nations took part. And the budget back then was slightly different to today. It was £760,000, whereas today is £12.5 billion, so a bit of an increase there. In terms of what is actually the infrastructure for the Olympic Games and the sort of tasks the client gave to us, we obviously, the client aspired to have the most sustainable games ever. And in terms of the master planners, the thinking that they did was to look at which kind of sporting venues can be reused as a sporting event. So for example, football stadiums, Wimbledon and Wembley and so on. But it left over, we also looked at what are the existing venues that could be reused as a sporting stadium, so Excel centers, Greenwich and so on. And then there were some temporary venues, and this is where Atkins was involved and did 150 of them in the UK. For example, beach volleyball, that was a temporary venue, put up and taken down in 6 weeks. And that left then whatever was required for the infrastructure on the park, like the aquatic center, the velodrome, the stadium, and what was used for handball, and an energy center on the park itself. So that actually brings us to what became what the infrastructure was, the structures, the bridges and highways, the parkland, public realm and utilities. So what you see there is actually how the park was divided into a north side and south side. And Atkins was responsible for the north side, and this is where I was the sustainability manager. Now this is the size of Hyde Park, 246 hectares. So obviously a huge coordination exercise. And you can see there are 3 rivers going through the site itself that sort of form some corridors for it. So if you were being asked to do the most sustainable games ever and you were setting that up, how would you actually achieve that? Well, the way it was done is that one of the big secrets to on the project was the way the project management and the procurement was set up. So for the sustainability, we had a sustainable development strategy, and that had 12 sustainability objectives. What was quite interesting and different was the fact that you had the engineering, the carbon waste and water setting alongside equality, diversity, employment and skills as criteria that had to be achieved by the project. We also had very specific KPIs, so the recycled content had to be 20% by value, recycled aggregate 25% by weight, sustainable transport 50% by weight, and reuse of demolition by 90%. So there was also what is called a procurement, which was called a balanced scorecard. So if you were contracted, you had to be scored on time, cost, program, but also sustainability and health and safety in, I can't say whether it was in equal measures, but it certainly was taken account of. Now that sustainable development strategy was translated into 6 what is called implementation guidance for project teams. So this is a way how this overarching strategy, what it meant to the engineers. So for example, in terms of particularly for materials, use recycled aggregate, use secondary materials wherever possible, and so on. So this is partly what my job was, to ensure this was embedded into the design. Another big secret was that we had to do CEQA for the Olympic Park. Now, that has never been done, a CEQA assessment at this size. There were 19 civil engineering projects. Each project was going to be assessed for both the client, the designer, and the contractor for each individual project, and this would be pulled together as in one overall score. This was like what is called the first bespoke assessment ever in the UK for civil engineering, and we had to achieve above 60%. Now, what did we start off with? Completely highly polluted industrial site that had been in a bad state for 200 years, old car tires, and paint, you name it. So there was actually a task of the Atkins enabling works team to clean it all up and do the, for example, archaeological searches and so on. So they found things like flint axes, prehistoric skeletons and boats and so on. And they did 3,000 site investigations. So overall, we cleared 1.3 million square meter of site clearance. Now, the other thing is that obviously the soil on the site was highly polluted. So for that, there was established what is called a soil hospital. So the soil was taken there, cleared up through soil washing or bioremediation techniques. And I always think about this as the Olympic Park's washing machine, and that the bioremediation is the washing powder, as when I explain that to a non-technical audience. Now, in terms of the Olympic Stadium, there's about 400,000 cubic meters of earth that had to be removed. But one of our big achievements is a lot of this happened ahead of program. This was delivered 3 months ahead of program. And below this stadium site, there was some groundwater which was polluted. That was cleared up by natural methods of using a bacteria called algae. Now, obviously, you want to hear about the infrastructure. This slide, in my view, is actually the secret to how we achieved a sustainable games. The reason for that is, if you go through it, you see there's a client, the ODA. The client employs engineers to deliver the park on their behalf. They then employ contractors like us to be designers. But it's this thing that if you look at the early design stages, those documents I showed you earlier sets out a guidance for the whole of the park. Think about it, during construction there were 11,000 workers on the site. Think about coordinating them and getting them to walk in the same direction and achieve those targets. And this is actually how it explains that through the main design, I will sit down, have workshop, explain, do calculations to see that we are on target, and I had to report back to the delivery partner to say we had actually achieved what we set out to do. If I was going to give the high-level explanations about, well, so what is sustainable infrastructure and how did we achieve it? But obviously, we use existing structures. Whatever had to be left for legacy would be designed as permanent. Whatever was designed and additional that would just be used for the games period would design as temporary, so could be taken away. I'll show an example for a bridge later on. Whatever roads would be designed would be aligned so they fitted a legacy as much as possible. We looked for the number of bridges that would be needed across the park, make sure we got the right bridges in the right places, only the ones we needed with the right width for the either legacy or games. Now what that meant is, for example, for highways, if you had a road that would stay for legacy, it would be designed for 40 years, but if it was for games only, it might be just 4 years. Now, similarly for the retaining structures, we look through and simplify the design, but also use reclaimed materials in the gabions. Now, the other secret was that the procurement on the park would be centralized. So, for example, the concrete, there would be a concrete supplier where everybody had to get their concrete from. So that meant that if you wanted to replace something with the recycled materials, then this would be actually easier to achieve for a great group of people. Now, this is actually wetland bridges. I promised an image of a bridge. And as you can see, there is a section of the bridge that's permanent that has a slimmer width than what's adjacent to it, which is the temporary bridge just for the games. Now, that would be taken away during the games. But you see some of the initiatives that I talked about, like we call it low carbon concrete. So primary aggregates have been replaced by secondary aggregates, like China clay sand and glass sand. And cement has been replaced by pulverized fly ash. Gable walls have reclaimed materials in it. I'll give you an example later on how we replace PVC with high-density polyethylene. But also you try to specify prefabrication, and we have created bird boxes using utility pipes. So actually the utility pipes that were left over on site got reused in those, so you can see them there in the image there. Those are bird boxes made from utility pipes, and we have sort of little openings depending on which kind of bird lives there. This has been a phenomenal coordinating and diplomatic exercise, because I had to get the ecologist to advise me where the birds would be happy, and the structural engineer had to be happy with wherever the bird's box went, that this is going to work and this will be fixed properly. And in order to achieve that, I said, right, what we will have is we will have bat and bird box documentation, and everybody would have to read it and agree with it. And actually, it had to be checked by 15 people. You know, health and security, health and safety, security, landscape architect, structural engineer, ecologist, the sustainability team, and the project lead. So everybody was sure we agreed with it. And you can see there, those are actually one of the drawings. And here we've also fixed bat boxes underneath the bridge. And also in terms of saying, how do you procure something that is a reuse? Now, according to European law, you can't tell someone specifically, you must do this. So you have to see something like this or equivalent within a minimum traveling distance to the site. Now, in terms of infrastructure, I'm quite humbled by how much is happening and how much carbon can be saved without realizing that. We take it for granted that our water and electricity get supplied. But here's an example of what happens if you replace PVC with high-density polyethylene. So for example, for drainage pipe, we've saved 45.5 tons for 1 kilometer of drainage pipe. And we've saved 513 tons of CO2 by replacing PVC with high-density polyethylene for 288 kilometers of utility pipes and ducts. The drainage engineer also looked at what products would replace gravel, and he actually found that there would be waste plastic can be used as a drainage medium, as you can see one of the images where the water runs out and through that medium there. Now, in terms of challenging curbs, traditionally we would probably use concrete curbs or granite curbs. But again, that was challenged. And for the temporary roads, where things would be taken out way after the game, we got plastic curbs, which are only 5.4 kilos, so very light, so can be easily laid down. It was much faster. But for the permanent roads, and obviously the people who adopt the site after the games has to be quite happy that the look and the feel of the curb. Now the look and the feel of the curb in the area would traditionally be a granite, and therefore we found something that looked like granite that could replace it, but had a recycled aggregate of content of 47%. Now, as you can see in that graph at the bottom, we actually managed to save the carbon by about 90%. So what was interesting at this stage in the project, we had much more information than in the early stages on how much carbon, certified carbon data for those curves, so we could calculate that very accurately. Now, what did we achieve in terms of the overall targets? As you can see, the targets I told you earlier on, but the North Park infrastructure and the wetland bridges, as you can see, there's almost like a factor of 2, if not a factor of 3 on how well we have done as a team both for Atkins, but also our competitors from the south side. You can see some of the achievements that helped doing that, which was like in the Gabion walls, there were the reclaimed materials. But the bottom picture with the road, that is an example of, for the temporary roads, we actually use something called foam mix. Now, foam mix means that you can actually use more recycled material in your highways or in your road, and you also produce it at a lower temperature. So those were some of the other initiatives that we had. Now, in terms of utilities infrastructure, overall, there was laid some like 6 kilometers of pipe work on the park, or 22 kilometers. Now imagine, you saw the park in the beginning, what it was like with, there were already utility pipes there are pylons and so on, and get that to fit and coordinate with 5 boroughs at the same time. So this is actually, they had a centralized coordination body just for the Olympic Park to overcome that. Now, and this is an example of how we put in new culverts in order to ensure that the overland water would be drained away, and therefore there were 4,000 properties that was less of risk at flooding. Now, this is obviously what you've seen on the television about how the park actually ended up looking like. This is a view from the North Park where we are responsible for the infrastructure, where you can see the bridges actually with the Legacy Bridge next to the Games Bridge, and the roads around the area. But I thought you might wanted to see a bit of green. So here is a bit of green, what it looks like in its beautiful stage. And when you see those sort of wetland, or next, our wetland engineers actually did some calculations on what, They did some calculations because the road next to, or the pathway, was too close to the river, so it started flooding. So they actually calculated how those pathways needed to be, and we also tested over 12 months which kind of plants needed to be in that area to make sure that they would survive and be happy. So you can see an example of this. This is like a before and after picture of the wetland engineers. You can see before, and here's it transformed into after, with beautiful frog ponds and benches that people sit on. And I was actually on the park during the games, and with lots of television screen. It's a really lovely area. I highly recommend visiting it. So what are the future opportunities? As you can see, that is the color for London 2012, just like my shirt. I had to wear that shirt today. So what are some of the challenges? Well, when we started off, and a journalist once asked me, so what was it like the first day working on the Olympic Park? I said, well, I went, and suddenly I was responsible for 150 people, and had to create the most sustainable games ever. You know, there was not kind of no roadmap. So obviously the scope in the beginning, the kind of really definite deadline, and getting the right people to do something that they may not have done before. But, you know, the sheer size, the sequencing, sometimes we had to start doing things before we were maybe quite ready for it. But also the profile. I couldn't go anywhere to any party or stand anywhere talking about it without people having an opinion about it, and certainly make sure they would tell me as well what they thought. So it has been PR training like nothing else. But it's sort of influencing people's design habits in a short space of time. But also, where do you target your efforts? What are the quick wins, and what are the more difficult ones that takes more effort, and therefore you might need to let go of? And as you can see, that image of the cauldron or whatever, actually, in terms of challenges and pressure, the guy who sized the pipe for that sits around the corner from me. And we sort of imagine having that turned on before it's turned on and have 6 billion people watching it. And sort of, you know, the certainty of getting that size right was, that's the kind of things we went through. But also, there was a very strong corporate social responsibility agenda. So we were actually out, you know, raising money for charity and so on, and balancing that with doing our day job. So what did we actually learn that we have actually written about in the Learning Legacy? Well, one of the things is, imagine in some ways, it was an occasion that Sebastian Coe would have to go and wear a second-hand suit at an event like that, because when you try to get somebody to use recycled and reclaimed materials, it's like, in some ways you're saying, well, just reuse those materials on site, they're great, aren't they? But obviously the second-hand suit gets cleaned up, so it's that whole process of engaging and with the client and saying, actually, this is just better than buying you, actually. We don't want to buy you. This is much better. And I've talked about the learning legacy. I'm a learning legacy speaker, but also we set up like a bespoke SQL system. We've learned from other industries like the army in doing temporary design, like beach volleyball. You know, who is faster than the army at putting up a new town and taking it down again? But also, when we're sort of doing design, really focusing on designing just what we need and just not pull out the codes and say what the codes tells us. One thing I also found was courage is quite key. If you like, the results you see there, 98.3%, that's the highest scoring project in the UK for SQL. And it was interesting to see what happened to us as a team when we realized, gosh, we've got the highest scoring projects. And to sort of just be bold and say, well, this is what we believe, this is what we have done. But I think what we learned the most is basically that change is possible. If you have the right leadership, you have client buy-in, you have a system in place that drives change, and where you're being audited against sustainability, and where you have the right skilled professionals in place, in the right place, you know, to support with the team and environment, then you can really change things very quickly. I have never experienced so much change in 18 months to 2 years in my professional career as London 2012 at Atkins, ever. Absolutely outstanding. So the good news as well for the industry is that Sir John Ahmed, the former chairman of the ODA, has written a report to the government on what can be learned from London 2012 and what should be taken forward. And he also talks about, you know, the how is project management, the procurement, and to take that forward. And that the UK TI should promote the ability we now have in the UK to do these major sporting events. Relaxing the marketing restrictions, use Compete For, which is a way of procuring, could be for procuring public sector projects. Now obviously the Learning Legacy website has actually been picked up by the government's major project department and is now still up and running. And the intention, I believe, is that other successful projects can put that information on there. He also recommended that small and medium-sized businesses should be helped winning work overseas as at the back end of London 2012. And the pictures there, you can see those are the design team members who actually achieved some of those carbon savings we saw earlier. So if there were any kind of solutions in terms of infrastructure, it's really London 2012 has proved it is possible to change a huge team very quickly in their design habits and deliver something that's highly sustainable. We've got the highest scores. There's nothing, you know, the lowest we've got in SQL is 88% and the highest in 98%. It just shows it's possible for anybody to do this. But also there was something about the client that we had and the way we worked together as one team meant we got there much quicker. We shared each other's specification, information, we shared each other's staff to get there. And I think this actually demonstrates, which is what certainly Atkins, we feel we have shown a feat of engineering, and we've taken engineering closer to the public and closer to the world to see what a fantastic field it is we work in. Thank you.